Today I want to talk about how o3b mPOWER offers performance above all. I'd like to talk about the predictable performance of o3b mPOWER. I'm actually going to start first with an example of LEO performance, so that the latency may not be as predictable for LEOs. So let's take a view of the Earth. And we have the LEO satellite in space. Now, just like MEO, also in LEO, the satellites move over the globe over time because they orbit the Earth at a different rate than the Earth rotates. However, being so close to Earth will introduce a couple of problems. So let's start with our gateway for uplink and downlink and the user terminal. LEO satellite has a smaller range, and their ranges are usually rectangular in nature. Now, as this satellite moves overhead, the beam of the satellite will have to move as well. But because of the smaller range, this terminal will leave this gateway at a certain point, and we'll need to connect to the next gateway. So let's look at that scenario and we can compare the two. We have our previous gateway here, our terminal. Now the new gateway. As the satellite passes overhead, you're actually going to move from this gateway to this gateway. Now what that means for your latency and your performance is that you're not only handing over from satellite to satellite like you do in any non-geosynchronous orbit, but you're also handing off from gateway to gateway. Each of these moments is a potential point of failure. Now you have twice the number of handoffs per satellite and many more satellites in orbit than in MEO. And furthermore, not every gateway is built the same. This gateway may have a fiber connection to a data center over here, whereas this gateway might actually be connected to a data center in another part of the world. So when you need to get back to your core network or your headquarters network or whatever it is you might be connecting to, as the LEO satellites move overhead, what you're connected to could actually change. So that 50 milliseconds of latency is just taking into account the distance here. But as things change, as the ground network changes, that latency can actually vary over time. And a variance in latency can actually lead to a problem called jitter, or may just plain give you an unpredictable connection. o3b mPOWER, on the other hand, avoids some of these issues. One o3b mPOWER satellite can actually cover quite a bit of the globe. In fact, the gateway and the user terminal are in different beams. And with the angle of o3b mPOWER, these two locations can actually be up to 8,000 kilometers apart. That means even as the next satellite comes into view and you need to do a satellite handover, or no matter the distance that this covers, you will always be able to connect to the same gateway from the same terminal. So even though our latency might look slightly higher than the LEOs at 150 milliseconds, this is an absolute predictable number. In fact, we're so sure of our 150 milliseconds of latency, it's included in your service level agreement. This is predictable performance, which leads to less jitter and better response time in your network. Now, you might see this difference and still think, well, 50 milliseconds, even if it goes up and down a little bit, still beats 150 milliseconds of latency. And what I would challenge you is that the difference in 100 milliseconds is fundamentally the blink of a human eye. For any human-based application, you will never notice the difference that 100 milliseconds gives. So for almost any application, it's better to be predictable than to be the lowest.